Good afternoon, everyone. It's 2 o'clock. We will get started. I see a few more people, but I'll start with a quick introduction and go from there. First of all, thanks for joining us today. To introduce myself, I'm Kishore Boyala Kuntla, Vice President of Products and Marketing here at RIZE. And before joining RIZE, 3 months ago, I was VP of Product Management at SolidWorks and been with SolidWorks for many years. So, um, so, so why RIZE and jigs and fixtures? A quick primer, probably. Anytime we manufacture parts, it requires manipulation and movement and position of components and assemblies. Sometimes your hands are not good enough on precision, for speed. On the manufacturing floor, jigs and fixtures are quite commonly used to position parts for any number of applications. And to produce good component parts for jigs and fixtures, you need few things, especially from a 3D printing standpoint. You need superior strength, and we will talk about the materials with which you can create jigs and fixtures here at RIZE. Likewise, you need high quality processes, repeatability, precision, and manufacturing precision and all that stuff. Also, jigs and fixtures for certain industries have certain requirements, whether you are medical or in other industries, and we will touch on those. And we go from there. Okay, so we talked about why RIZE. Here's an example of a thing, jigs and fixtures created in RIZE. Basically, we are using it to secure, manipulate workplaces, improve accuracy and interchangeability, and obviously increase efficiency. The first 3 or 4 slides will move through quickly. A lot of times, what is a jig? What is a fixture? This is discussed quite a bit. It depends on the application. A fixture, obviously, as its name sounds, is a component that's been fastened into place on a rigid surface, used to hold workpieces to securely component alignment. A jig is used to hold workpieces securely, but may not be fastened. They are used to guide tooling or sometimes workpieces to get the job done. And in both cases, some parts see some heavy loads, and we will talk more about some strategies to use to leverage doing this in RIZE. We have customers that are using the products for jigs and fixtures, for clamps, work holdings, and brackets. Like every device, there are some benefits to what we do in RIZE with respect to materials. There are some areas where we are not a good fit, and I will talk about those as well. Okay. So why RIZE? One is to the material that we have, that is called Rizium. It has superior material strength. You can actually very quickly, and one of the benefits of doing jigs and fixtures in 3D printing is you can customize things fast, as well as you can revise components very quickly. The other things that our customers really like about using the RIZE methodology is an ability to do marking. And you can see here some instructions. These are voxel level marking that we do inside the printer. And you can obviously give different dimensions here. So it's much more easier for people to use as they use the RIZE created products. Here's an example of one such fixture and a jig right here. It's a multi-tool bottle opener. As you can see, it's fastened to the ground. There are a couple of things I hope you notice. One is this QR code right there. It kind of links the part and you can serial control it. You can insert metal places in this case for the strength of the hook. And a lot of times have this where when you have a jigs and fixtures, you add some additional to basically strengthen the part. Sometimes you insert some metal clamps and other things, to make sure it's stronger to get the job done. Okay. So why RIZE? One of the materials, or the material that comes with RIZE, is and it's a very high-end engineering compound. And here's an example a customer did of functional strength tests. You can see ABS right there. You can see onyx, machine nylon, RIZE 1, nylon with carbon fiber, nylon, and PCABS. And you can see that with respect to RIZE or Rhizium 1, the way we print with best-in-class Z strength, it can go almost, in this particular example, up to 220 pounds of force before it failed, and you can see how it compares to other materials. The point being, with RIZE and the Rhizium material that we have, you have very high strength with which you can design a jig and a fixture and put it in end use cases. So just more quick introduction to Rhizium 1. Here is the table, I guess. One of the things is the ingredients that make up Rhizium are all USP Class 6 certified. We haven't certified the end material per se, but it is used by many customers in the medical industry because it has very good chemical, it doesn't react much with chemicals. It has very negligible moisture absorption, less than 0.01%. So you can actually handle this material. You get the material, put it inside the box, put it outside for a few months. When you go to print, you get very high quality parts. And once the part is printed, basically it doesn't change shape or it doesn't wick moisture over time. It has very low coefficient, very good volume resistivity. And also this particular material is used a lot in the semiconductor industry for packaging, for part designs today. So this particular material, it's a high-end engineering compound, and you can see here compared to ABS, how does it score in terms of properties with respect to polycarbonate and such. I would also like to show you the spec sheet itself. Let's quickly take a look. This is the Rhizium spec sheet, and it's an engineering grade amorphous polymer, obviously designed for high strength, superior layer adhesion, long-term stability, and clean operation. One of the benefits of Rhizium is as zero VOC. It doesn't emit any volatile organic compounds like styrene or anything else, which means you can actually put it in closed enclosures quite safely without having to worry about any outgassing or anything like that. Also, it is a amorphous material. Its RIZE is fully thermally controlled. So when you close the door, the entire chamber is heated up. So when you actually print parts, it's in a controlled environment. And here you can see the flexural modulus of the part in XY, XZ, and ZX direction. So your Z strength, it's very close to the XY strength as well. And that's why we say that you have best-in-class Z strength when you actually print parts with Rhizium and RIZE. And obviously, you can see the flexural modulus with ISO 178 method A testing. See the volume resistivity, dielectric breakdown. The glass transition temperature is around 99 degrees. A lot of customers ask us that, and heat deflection is around 86. There is a flame classification for this material as well, and the rest of the stuff. You can get this from our website. I won't dwell on too much on the material property. So obviously, what this shows you is when you design with RIZE and the Rhizium material properties, because of higher strength than ABS, polycarbonate, polypropylene, and such, you have high strength in all three axes, as well as you can tolerate high stresses and loads when you put it under a jigs and fixtures kind of scenario. The only caution I have on this material is what we find is that when you have oil-based coolants, especially in CNC environment, it doesn't handle that very well. So our customers actually print multiple fixtures and they just and the jigs, and they take it to the CNC and get the job done. Other than that, if you have a water coolant or anything like that, because of its negligible moisture absorption, it handles those extremely well. So how does this work? Here's an example. Obviously, there's SolidWorks right there. We call this one touch because it's very, very easy for engineers, CNC users, anybody in the company to go. With one click, you can export to RIZE. Once you do that, this is our slicing software. And here you have full marking capabilities. So the way you do that is, in this case, you go to views, you go to the front view, take the part to that view, and you can bring any image for that matter, and you can scale and position that, and it automatically conforms to the geometry. And this is how a lot of customers are putting their part numbers, manufacturing instructions, assembly links to assembly instructions and such, dimensions, key dimensions, and all that into the part for collaboration. Here's an example of metadata. Basically, you put that into a QR code, drag it and drop it on the part, and very quickly now you have your logo, you have your part numbers, your QR codes linked to metadata on your particular model. So once you do that, you click prepare job, it automatically creates the supports. You don't have to do anything else. And at this point, you go to the printer. So it's a hybrid printer. You never have to level the plate. It's automatically leveled. It has magnetic build plates. You just slide it into place. You have filaments, you have marking inks and release inks already there. You select the part that you want to print and hit print. So that's how simple the process is to go from a design to printing. And at this point, what you see is the build plate come up. It's a shoebox size, and obviously the print goes through. As I mentioned before, you have two spools of filament in the printer with a hot swap capabilities, so you never have to worry about running out of filament as you create the part. Also, along with this filament, we have this process called APD, which actually puts release ink and marking ink. And what this release ink allows you to do is very easily remove the supports. So everywhere there is a support touching the part, we put a layer of the release ink, and once it comes out of the machine, you can very quickly peel away the supports, and you're all set. The other thing I will say is regarding the inks itself. These are functional inks, and what we mean by that is you actually have voxel level penetration for the inks you put on the part. There it is coming off the print bed. You can see how the supports come out. And you can see one very quickly you remove the supports, and because of the release ink that's there in between the support and the part, and there's your part in hand. So that's how the printer works. And once it's done, you can go to the QR code, just click on it, and you have the entire metadata that goes to the part. And I'm sure you found this as you 3D print parts. After a certain time, it's very hard to figure out basically which part that is, which jig it was, when was it manufactured, when was it, who is the creator. You can put all the data into your PLM, PDM, ERP systems, link that to the part. So now you have your digital continuity from design all the way into the 3D printed part for IP protection, for traceability, and all that good stuff. So as you can see, it's a hybrid printer that not only extrudes Rhizome, but also puts voxel level inks that go into the part for any number of use cases. So let's continue this. So talking about jigs and fixtures for life sciences. I don't know how many of you are familiar. FDA actually in December last year released a guidance on 3D printed parts for life sciences industry. Obviously, 3D printing is having major impact in all industries, including life sciences. In the case of life sciences into surgery, healthcare, pharmaceutical, personalized medicines and such, and also with end product visualization. And what it basically means is, and this is some of the things that FDA talks about in its guidance. They want a clean, zero VOC, clean materials process, which RIZE does that very well with the Rizium material, as well as the print process. They talk about to FDA 21 CFR 820.30 design control requirements. This is both on the design side as well as the production side to a certain extent. So with our marking, you have full traceability and you can comply to this requirement as well. Very low moisture absorption. Also in the document, you will see in the FDA document, they talk about document, describe, and identify 3D printed parts for QS regulation. And you can see here is an example of our customer ConMed that created molds. You can see this soft material mold that they do here. And you can see the date it was printed. On the other side, there's a part number and all that good stuff. Now, the other nice thing about the Rizium material is it has very low surface energy. So when you create molds out of Rizium, you don't have to put any mold release agents. The parts come out very easily. And so not only is it good for jigs and fixtures, it's actually a very good use case for molds and mold creation. Obviously, in this case, these are low temperature, hardening materials here. And you can see a part that, in this case, ConMed has created. Okay. The last thing the FDA actually talks about is geometric integrity. Because in RIZE, the supports peel away without leaving surface marks and residues, it doesn't impact safety and effectiveness of the products. And this is another use case our customers tell us that they like about RIZE. There's another use case we are seeing, whether you do jigs and fixtures or any number of parts, is digital part management, manufacturing on demand. And this allows you to save on inventory management, short turnaround times with RIZE. You can manufacture at the point of consumption and serial control with IP production and marking inks. And we all know that anytime you have a part in inventory, it's very expensive just to manage it and maintain it. And in this case, sometimes customers, and I'll show you an example, they create an inventory of jigs and fixtures. And with RIZE, because it's serial controlled, you just manufacture on demand and go from there. Here's an example of how this secure digital inventory works. The part comes out, you have seen the QR code. I'll just move this forward fast enough. And once you log in, there's a part with all its records going with it. Okay. So with jigs and fixtures, with RIZE, you can actually have digital part management as well for very simple pre-processing and post-processing. And that's why a lot of our customers tell us with RIZE, you have the fastest to fabricated part and at the lowest cost of ownership, because we have one of the lowest material costs in the marketplace. You can document, describe, and identify with traceability. You get best-in-class Z strength, so you get your form, fit, and function, and zero VOC, which means it's safe operation, and you can keep it in a desktop environment, industrial environment, and get the job done. We have seen many RIZE printers on the manufacturing floor with CNC users using it because it's fairly simple and easy to use. Many applications in life sciences, for manufacturing, for defense and aerospace. I don't want to get too detailed into this. One of the things that a lot of customers like is the fact that it mimics injection molded strength, and it supports all geometry types. And you can see some of our customers doing that with the RIZE products. Let's take an example of one of our customers, New Hudson Facades. We never expected that someone in AEC industry would be using our products, but it was quite interesting to us that they have a RIZE printer, and they are doing work holdings, they are doing fixtures, gauges, functional parts for production. And you can see here a facade that they are assembling using the RIZE. And the users are CNC programmers, engineers, and managers, so everybody across the board. We were pleasantly surprised when the engineers at New Hudson Facades told us that with RIZE they are saving up to $200,000 a year, which is less than a 3-month ROI. They went from $200 to $50 per part. They had other 3D printers in the house. Now most of the 3D printing is happening in the RIZE printer. It's running 24/7, 15x in speed in assembly inspection times, and they're seeing a 15% increase in production speed as well. A lot of our customers tell us that the parts that are printed are within tolerances of the design, within design tolerances, which is also a lot of users are looking for when you talk about end-use parts. So I won't repeat. They're averaging 2+ parts a day. These are very complex, big parts, and obviously they're doing it in 24/7 all the time. So very quickly to review, why jigs and fixtures? To improve accuracy, repeatability, and efficiency. For strength, speed, and marking annotations with RIZE. As we discussed, Rizium as a material is a very high-end engineering compound. Its strength is twice plus that of ABS, stronger than polycarbonate and polypropylene. You get equal strength in all X, Y, and Z direction. It's an industrial 3D printer. It's with full thermal control inside, so it's a heated chamber. So you get very high strength parts. It's designed for strength and support repeatability. This is another huge advantage our customers tell us is time to part, which is it's the fastest with RIZE because there's very little pre-processing and very little post-processing. Supports peel away, easily removable, and go from there. And the range of application stretches. In fact, one of the things that we take a lot of pride in is when customers buy RIZE, they say they are buying it for a certain application. Few months later, number one, we see the machine running all the time. And number two, they have expanded the scope of application to areas even they didn't imagine, into new areas, solving new problems inside the companies. And by users, they never expected 3D printing would be used. That's whether it's engineers or managers or people on the shop floor using RIZE to get the job done. So with that, we said it's a 22-minute plus webinar with time for Q&A. If you have more questions, please go to rize3d.com, which is RIZE3D.com. There's a wealth of information there. And you can always reach out to us if you have any further questions. Okay, I will stay here for the next few minutes for your Q&A, or we'll be more than happy to have a side discussion if necessary. Thank you very much.